This model that you see here is a replica of the first atomic bomb that was used, and that was in Hiroshima. Inside this bomb, there were 60 kilograms of uranium-235. When it hit the ground, it exploded, and the explosion it created was equivalent to 113 kilotons of TNT. Many 13 kilotons means 13,000 tons of tin. The uranium inside this canvas had split into two parts. 40% of it was in the hole, and 60% was placed in the form of a bullet near the end, and this bomb worked in such a way that behind the 60% uranium, they had placed a certain amount of explosives that would explode and quickly send that 60% uranium to the 40%, and that's what the atomic bomb is. You know that no country gives anyone the plans to build its nuclear bombs, and everything is done out of kindness. That's why the explanation we've given about the inside of this bomb is the simplest definition that can be provided. Now let's get to know this bomb a bit more and see how it was constructed. We need to understand that the most challenging part of this bomb at that time was obtaining uranium-235. If you've seen the clip about the most dangerous metal in the world, you're familiar with uranium and its reactions. But here, we should also mention that natural uranium is uranium-238. And if we want to make a bomb, we need to convert that uranium into uranium-235, which has just 3 fewer neutrons than uranium-238. Essentially, it needs uranium-235 in order to be able to carry out nuclear fission, something that uranium-238 cannot do. And do we know how uranium-235 is extracted from uranium-238? At that time, scientists realized that uranium-235 is significantly lighter than uranium-238, and this led to the production of uranium-235. At that time, using the most primitive method, which involved very long tubes. For example, they would lay pipes between Los Angeles and New York and send uranium in gas form through these pipes. The distance between New York and Los Angeles is about 4,000 kilometers. When the uranium gas passed through this pipe and reached New York, at that moment it was initially uranium-235, which later turned back into uranium-238. So why was it uranium-235 at the beginning of the tube? Because it was lighter and reached the destination faster. This method produced uranium-235, but its purity was low. In order to further refine this and achieve 90% enriched uranium, they would cycle the uranium back and forth, 4,000 times in this direction to increase the enrichment percentage. But after this idea,
a better method was found, which was the centrifuges that we all know about. The centrifuge rapidly spins uranium-238 gas, and the centrifugal force causes the heavier uranium-238 to move outward, while the lighter uranium-235 stays in the center.
The centrifuges, as you can see, work side by side and are interconnected. Uranium goes from one centrifuge to another, becoming slightly more enriched until it reaches the desired stage. To obtain 30% enriched uranium, it has to go through 60,000 stages just to reach that 30% enrichment. The more processes applied to the uranium, the more enriched it becomes. Of course, the centrifuge itself is a technological marvel, and we simply put it this way: it doesn't exist. Don't think of the centrifuge as spinning like an air pump. This is one of the fastest rotations of any device. The rotation speed of a centrifuge is 1,500 revolutions per second. Do you know what that means? 90,000 revolutions per minute. Now think about how this device should be built so that it can run at this speed. Of course, enriched uranium isn't just for making bombs. It's mostly used to generate electricity. It's used to power large submarines, large military ships like this, and aircraft carriers. When you say a ship with nuclear power can sail for about 30 years without any power, why don't they use this power for cars? Why isn't it used in trucks and cars so that power isn't needed anymore? Because uranium has to be in a place that is 100% safe. A car that isn't safe could crash at any moment. So storing uranium in that car is kind of impossible. Otherwise, the whole world would be contaminated.